What's going on, guys? Let's look at this problem right here. Here this question is asking to calculate the effect of ripple at the output of the circuit in this figure. We can assume VCC is small signal input and determine the small signal gain from VCC to Vout. Compute the gain assuming VA is less than infinity, and this is the question we are going to do. Okay, now it's VCC if it's a BJT transistor, but here we have a MOSFET, so this is VDD. So instead of this VCC, we had to think it like VDD because I did this same question for BJT before. That's why we have VCC right here. Now we are going to do it for VDD. Now let's go ahead and draw the equivalent model of this circuit. The equivalent model will look like this. Plus minus V in and G VGS here, RS GM VGS RO D, then here we have RD, and this one is VDD. Okay, this is the equivalent model of this circuit. Now let's go ahead and apply current circuit equations for this circuit. Circuit equations. The first equation we can write is Vout. Vout is equal to VDD minus IDRD minus IDRD minus IDRS. And another equation we can write, Vout is equal to we can simplify this equation, VDD minus if we take ID common and the negative outside, so we are going to have RD plus RS because we have a negative outside. Let's call this one equation number 1, and Vn is equal to VGS plus IDRS. ID is equivalent to V in minus VGS divided by RS, and if we substitute this one for the equation number 1, if we substitute this one into this equation, this will become Vout is equal to VDD minus, instead of ID we are going to plug this one, so this is going to be V in minus VGS divided by RS VDD times RD plus RS. Therefore, if we write this one in terms of V out over VDD, to write for V out over VDD, we had to divide everything by VDD. If you do that, this is going to be V out over VDD, and this will become 1. And here we will have previously it was RS alone. I forgot to put this this VDD comes after this. Okay, let's continue. Vn minus VGS RS times VDD, and all things multiply by RD plus RS. Now this is it. Now let's go ahead and write this is V out over VDD, that's what they asked for, 1 minus V in minus VGS over RS VDD. Now instead of this VDD, we can create an equation for VDD and substitute that one. To do that, I'm going to use equation number 1. This equation, the simplified version, let's go ahead and write this one. Let's rearrange this one in terms of VDD. If we rearrange this one in terms of VDD, this is going to become Vout plus ID times RD plus RS. Okay, then if we take a ID common, actually instead of this, okay, we have Vout is equal to ID times Vout. We can replace Vout with ID times RO plus ID times RD plus RS. Therefore, if we take ID common, this is going to become RD plus RS plus RO. Now what we are going to do is, instead of this VDD, we are going to replace that one with this create and this new equation. Okay, that's the only difference, and that's going to be our final answer. So let's go ahead and write that VD over Vout, actually Vout over VDD, Vout over VDD is equal to 1 minus V in minus VGS divided by RS times VDD, that is ID times RD plus RS plus RO times RD plus RS, and that's our final answer. I hope you guys find this video helpful. Thanks for watching, and if you're trying to learn electronics too, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.